Welcome to Teen Up, a podcast that digs deeper into the thoughts of teenagers' mind about the wonders of the world.
If you're new here, I'm your host, Isabella.
And I'm Glenn. If you're not, welcome back.
Here is a quick disclaimer. We are two teenagers that are doing our best to research everything. However, we are not experts, so if we offend anyone or say something wrong, we want to apologize in advance. Please email us to tell us what was wrong. Thank you. This week, we are back with other theories that include different viewpoints. In our first episode, we talked about the Big Bang, and now we are back presenting another theory that defies the Big Bang.
So the theory that we will start with is called steady state model. It's kind of like the alternate model of the Big Bang. So let's talk about what steady state model first, and then I'll explain it further.
Sure.
The steady state model is saying that our universe is expanding at a steady rate.
Right.
So in this model, our universe is also expanding because back then, people actually observed that our universe is expanding.
Right.
So it's a fact back then. So they know for sure that our universe is expanding. And in steady state, it said that the universe, like there will be new galaxies and planets and stuff when our universe is expanding because there will be new space in between, right?
Right.
So it's saying that instead of planets getting further from each other, there will be new planets in between them.
Wait, so how are these... So planets are just gonna form because they're in new space? There's like more space.
Actually, I'm not sure, but things can form from energy. So I saw this graph that compared steady state theory and the Big Bang theory. So both of them started with like this smaller circle.
Right.
Inside these two circles, there are dots. So let's say both of them have 4 dots. So the Big Bang will keep expanding, like the outer circle will keep expanding, but there will always be only 4 dots.
Oh,
But for steady state, as the big circle is expanding, more dots will appear in the circle.
Oh, okay. Oh, so it's like the ratio. Like if the space is bigger, more things are gonna be in this space.
Like the density of the whole thing is going to be the same.
Oh, right.
Okay, so this theory was debated like around 19 something. And actually Albert Einstein like supported this theory for a short period of time. And some people that also support it is Fred Hoyle. And that person basically worked a lot on this.
Oh, okay.
But so the thing about this theory is that this has been proven wrong.
Why?
So do you remember the cosmic microwave background from our first episode?
Right.
So for those who don't remember, it's a microwave background that exists in our universe because our universe has been expanding for
a very long time.
And there are wavelengths that was originally light, and now they are microwaves.
Okay.
Okay. So back when they were debating the Big Bang theory and the steady state theory, people haven't discovered the cosmic microwave background. So after they discover that, it basically proves that our universe is expanding at an increasing speed.
Right.
So because of this cosmic microwave background and what scientists has observed does not agree with the steady state theory. And also another person that proved it wrong was Friedman. So he's like this scientist mathematician, and he proved the model that Albert Einstein originally brought up wrong with math.
Oh, wow.
So that's pretty cool. It's saying that how there will be like no new planets forming. Yeah. So it's just another theory that has popped up in the history.
Oh, that's pretty cool.
Okay. So this one is a model that was proven wrong.
Yes.
So there's also another, let's say, theory that people talk about. It's called the multiverse.
Oh, okay. What is that?
And this one's actually pretty fun. And so the multiverse is saying that like we have a lot of universes. Universes?
Yes. Yes.
I feel like this is pretty self-explanatory, saying that it's like multiverse, but I'm still gonna point out a few interesting stuff about it.
Okay, so this concept of multiverse was introduced by Hugh Everett in the 1950s.
So other than our universe, like outside our universe, there's gonna be another universe and, you know, a lot of universes.
Right.
So the graph, because we were talking about graph earlier, the graph of this theory is more like bubbles.
Okay. Okay.
These bubbles are like our universe is a bubble. And the other universes are different bubbles. And we all exist in this, you know, void. And, you know, bubbles can collide. Bubbles can split. You know, bubble stuff.
Right.
Anyways, I also saw that on the internet, people are saying that there are different levels of multiverse.
Right.
So it's called tag marks for levels. So level 1 is our universe.
Okay.
You know, our universe, we have same physics laws, same, you know, physics constants and all the stuff. And at level 2 is universes with different physical constants. It's basically saying that physics law works different.
Different universes.
Yeah. And level 3, it's getting weird. It's saying you have different quantum mechanics. Which is, you know, not really easy to think about because quantum mechanics is already a very hard thing that, you know, we both don't know.
Right.
Okay. So level 4 is kind of like the ultimate multiverse.
Okay. What is that?
So this level is saying that all universes are equally real.
What do you mean?
It's basically saying that we have different universes. And in this level 4, it's the most difference that universes can get. Like there isn't a level 5.
Okay. So like that's like the ultimate universe.
Yeah, like they are equally real. Like that is the only, maybe like that's the only same thing that these universes have.
Okay. This is very hard to understand.
Yeah, I feel like that is really strange.
Okay.
But yeah. And so there are some things that are connected with multiverse. Like parallel timeline.
Oh wow. That's a lot of things mixed up together.
Yeah, but I think in Back to the Future, you ever seen that movie?
Yes. Absolute classic.
I think Doc explained the parallel timelines once.
Oh, really?
Yeah, it's saying how there are like different timelines going at the same time and they're doing their own stuff. But when you time travel, you create this new timeline. And yeah, I feel like multiverse, for me at least, is kind of like that.
Okay, that makes sense.
Yeah, but I feel like that's, you know, getting into time and it's going to be more complicated.
Right. Time is a very complicated thing, I would say.
Yeah. And for the cosmic microwave background, which is, you know, always brought up to support the Big Bang Theory. So one thing that was mentioned in the multiverse is that they are like cold spot in the cosmic microwave background. And people that talk about the multiverse say that it's the imprint that collision happened before. Like our universe collided with other universes, creating this cold spot.
Oh, okay.
I just feel like the multiverse is even more complicated.
Definitely.
Because it doesn't really, like, I feel like the multiverse can exist with the Big Bang Theory at the same time. Like, it's not directly against it.
But it has different viewpoints, definitely.
Yeah, definitely. So one interesting thing that I noticed about the multiverse is that, do you know about the flat Earth?
Yes, the flat Earth theory.
Yeah, and I actually heard people say that outside, like our South Pole,
Right.
is like, around the Earth, because we are a flat plate.
Around the Earth. Oh, right.
Like the rim of our Earth. And saying that outside that South Pole kind of thing, they are like other worlds that are also flat. Just like a bunch of plates laying on the desk.
Oh, wow. So can we go past the rim?
I don't know, but it's, it's flat Earth. It's another thing, but it just kind of remind me of that because, multiverse is like bubbles in
Oh,
space.
yeah. Oh, that's an interesting connection.
Yeah. These theories are just making things more complicated.
Right.
And multiverse theory is kind of like connected to string theory, which I heard it before in the Big Bang Theory, the show, not the actual theory.
Right.
But it just sounds very complicated.
Yeah, I saw it online too about like doing research, and I saw it. I couldn't get it either.
Okay, so we talked about two very confusing concepts, and now we are going to take a break. So after the break, Isabella will be talking about theories from philosophy. Welcome back.
So now we're going to talk about a philosophical concept called nothingness.
Okay. Tell us about it, Isabella.
So this concept started from the 5th century by a Western philosopher called Parmenides. So he was a Greek philosopher of the monist school. Nothingness is nothing, right? We've said this in like the second episode talking about the myths. It was a really hard concept for people to understand. So here's what he said about nothing, and he believes that nothing cannot exist. So his way of reasoning is that to speak of a thing, one has to speak of a thing that exists. Since we can speak of a thing in the past, this thing must still exist now. And from this, he concludes that there is no such thing as change. So what this means is that whatever happens in the past and we can speak of it right now, it's something that still exists. Like, this is logically very correct, but that is not the fact from what we know, because the past does not still exist. Do you get what I mean?
Is he saying that the past still exists because we can talk about it?
Right. So basically what he means from this is that nothing changes because they all still exist.
Oh, it kind of reminds me of realists in international relations, since I'm taking that class.
Mm-hmm. Tell me about it.
It's saying that realists believe that humans don't change. Like, human nature is human nature and we don't change. So yeah, basically that's what they're talking about. It's like people cannot be changed. So they have some beliefs about human. Like, what they're saying is that international groups wouldn't work because human will always act in their best interest.
Oh, that's a cool concept.
Yeah.
Wow. Wait, you guys learned very interesting thing in international affairs. Okay, anyways. So Parmenides has actually influenced a lot of other great philosophers such as Socrates and Plato, even Aristotle. So what I said just now was that what Parmenides said was very logical. However, it does not make sense when you are looking at facts. So Aristotle says, although these opinions seem to follow logically in dialectical discussion, yet to believe them seems next door to madness when one considers the facts. So yeah, that basically means that. And even in the 1900s, Albert Einstein has similar thoughts as Parmenides. So when one of his friend died, he told his friend's wife that now he has departed from this strange world a little ahead of me. That signifies nothing. For those of us that believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. So what he means here is that even though this person is gone, he is still somewhat present in this world. Do you get it? Like, time is not really a thing.
Okay, I'm confused.
Right. It's really hard to explain. So he says like past, present, and future is only a stubbornly persistent illusion, which means that time here is only a thing that humans actually invented to just keep track of things, I would say.
So is he saying that time is fake? Or like time is just a concept? It's not a thing that actually exists.
Right. Yeah, from his viewpoint here, like I said, it's very similar to Parmenides because they don't believe in change.
Okay, why does that mean they don't believe in change? Is it because so for Einstein, because time is the same, so
right,
things from the past that we know of the past still exists today because time is an illusion.
Right.
Is that what makes them similar?
Yeah, I would say.
Oh, okay.
So, as I have said before, Aristotle was also influenced by Parmenides. So, by distinguishing things that are matter and things that are space. Okay, so he believes that space is not nothing, but it is a place or a space where matter can be placed.
You mean nothing or a space?
A space. Because he thinks that space is not nothing, right?
So he thinks that there is no void.
Right.
Oh, okay. So he's saying that the void doesn't exist. Not like it existed because it's the void.
What do you mean?
I'm saying that a void doesn't exist because it's a void.
Right.
Because it's already nothingness. So it doesn't exist.
Right. So like Aristotle was influenced by Parmenides, right? So Parmenides doesn't believe in nothingness because if we could talk about it, it means that it still exists.
It's somethingness.
Right. No, I guess that he just doesn't take this into any consideration of like his philosophical thoughts.
Oh, okay.
Okay, so like Aristotle basically believes the same thing.
Okay, that makes sense. Now it makes sense to me.
So here's this other, like this is from the Western culture, right? And for the Eastern culture, basically, Eastern people, a lot of them believe in Buddhism. So Buddhism believe in nothingness because it is like a state of mind that they are all trying to achieve, because this allows one person to be totally focused on a thought or activity at a level of intensity that they would not be able to achieve if they were constantly thinking.
Oh, right. So I know that because like Buddhism, those Buddhists, they meditate all the time, right?
Yeah, they're trying to cleanse their thinking.
Yeah, so they go to like mountains and live in mountains and also they become vegan.
Yeah, they're trying to just, make their life as simple as possible.
So they're trying to achieve nothingness.
Right, but this is like a little bit different from what we were speaking before because this is a state of mind. It's not like a
physical space.
It's not right. But yeah, this is just another way of speaking about nothingness in another culture.
Oh, okay, it's interesting. Because
right.
If you think it not as an idea of space, but as a state of mind, it kind of makes more sense.
Right. It does. But like what we discussed here definitely does not I don't think it really further explains anything to like how to conceive nothingness. So basically, these philosophers sort of avoid thinking about this because it doesn't make sense to them.
What do you mean?
Like, Parmenides just believed that there was nothingness does not exist. So then we wouldn't have to understand how to.
Oh, that's their trick of answering things that they can't answer.
Like, avoid it. But no, I'm not. But they are great philosophers. Okay?
Yeah, of course.
Yeah. So that is basically it for the concept of nothingness. Yeah, I guess the takeaway here is don't think about it. Don't try to understand something that you can't.
Sometimes we just think too much, right?
Right. I do think so.
So maybe being simple is better, like the Buddhist thoughts.
Right. Don't think about it.
Yeah. So this is the third episode of our first season. And in these 3 episodes, we talked about the beginning of the universe. And we talked about different cultures, different beliefs. We talked about nothingness. So next week, we're going to be back with our conclusions.
That's right. Thank you for listening to this episode. Remember to like, subscribe, and share our channel.
Also, comment down below if you have any thoughts. You could click on the bell to get notified when we upload a new video as well.
Thank you and bye.